G'day guys, it's the Aussie Engineer here today, and today we're going to go through how to create the quadratic formula to solve the quadratic equation from first principles. It's a little bit challenging, this one, which is why it's a good one to actually think through. And just as a bit of a revision, obviously the quadratic formula is going to be y equals ax squared plus bx plus c. And we want to solve that when y equals 0, which gives us the solution of x equals minus b plus or minus square root of b squared minus 4ac, all divided by 2a. So let's get straight into it today and bring up the whiteboard for this. So let's start by just writing down our quadratic equation, obviously being y equals ax squared plus bx plus c. Now we want to solve this from when y equals 0. What does this actually mean though? What are we trying to actually look at? Now if I draw a graph over on this side really roughly, and excuse how terrible my graph drawing is today, and we have our equation y1 here, what we are looking for is when this vertical axis, y-axis, is equal to 0, which is therefore these two intersect points. Now in some later videos, I'll go into exactly why this is actually really quite useful. Needless to say today, just trust me when I say that it is, and we'll cover later down the track specifically why it is so useful to be able to solve that equation. All right, so let's go straight in and set, in this instance, y is equal to 0, and then start solving our equation. So 0 equals ax squared plus bx plus c. Now I like at this next step to tidy this equation up, so I am going to flip this equation across and divide everything by a. So we end up with x squared plus b on ax plus c on a equals 0. Now we'll take the c on a onto this other side, so we will end up with x squared plus b on ax equals minus c on a. Now, these steps so far, you'll look at these and you will not probably be able to immediately see what is the next step on this. So I'm going to show you what the trick is. So let's take x plus d, and I'll show you why I use d in a second, all squared, and let's expand that out. So what does that equal? Well, that equals x squared plus 2dx plus d squared. Let's leave that there for a second, and I'll come back to why that's relevant in just a second. So if we have a look at what we have at the moment, so we have x squared plus b on ax. What we really would love to do would be able to break that down into something that looks a lot like x plus d squared. So if we look at this and we have a look at the part next to the x, we want that to be something that is 2d. So let's write that over here. So we want b on a to be equal to 2d. Obviously, divide both sides by 2, and you end up with d equals b on 2a. Now, to make our equations match, that would mean that d squared is equal to b on 2a all squared. So when we come back across to this other side, and this is the trick, what we want to do is we want to add this to both sides, which gives us x squared plus b on ax plus b on 2a all squared is equal to b on 2a all squared minus c on a. Now, if you have a look at this side, now what we have is we have an equation which is in the form x squared plus 2dx plus d squared, which therefore means we can simplify that down to x plus d, but we know what d is, so let's not write d. X plus b on 2a all squared, which is equal to b on 2a squared minus c on a. So our next step from there is we go x plus b on 2a and take the square root of both sides to clear out our squared from this. So this equals plus minus the square root of b on 2a squared minus c on a. What I like to do now, this next step, and before I actually do this step, just remember why we're adding the plus minus onto this. So if we take this entire right-hand side of the equation there and square it, it doesn't matter if it's a plus, because if we square it, so if we consider a all squared is equal to a squared minus a squared is equal to a squared. Which is why when we now take the square root of both sides, we need to add this plus minus on each side. So let's just get rid of that. And we can also get rid of how we've got to where we are now. All right, so let's continue. What I want to do now, leave this side as it is for 1 second. And then I want to expand this expression here. So we end up with the square root of b squared divided by 4a squared minus ca. Continue on the other side of the page. b on 2a equals plus minus. And we want to put all of this over a common denominator. So square root of b squared on 4a squared minus 2ac divided by 4a squared. Now that this is all over a common denominator, we can put those all together. We can also take the square root of it, so we end up with x plus b on 2a is equal to plus minus of the square root of b squared minus 2ac all over 2a. Now, lastly, we want to take b on 2a from both sides. So we end up with minus b on 2a plus or minus the square root of b squared minus 2ac all over 2a. Obviously, we can put that together, and what does that give us? X is therefore equal to minus b plus or minus the square root of b squared minus 2ac all over 2a. So we finally got there. And it's a bit of a journey, as I said, and it's a little bit, the first time you will ever do this one, and the first time you'll see this, it'll be a little bit tricky. But once you know that trick, it's actually pretty simple to be able to calculate this yourself. And to be honest, this is one of those things that you should, with a little bit of practice, be able to do very easily. But also understanding this will help cement inside your head the actual quadratic formula, which will make it easier to remember going forward. So one last bit that I will close out is just for you to consider a couple of different points in the solutions to this equation. So there are three options when it comes to actually putting numbers inside this equation. They are going to be the first one, when this equation inside the brackets is equal to 0. The second one is when b squared on 2ac is greater than 0. And the last one is going to be b squared minus 2ac is less than 0. In the case that this is equal to 0, then this removes, there's no plus minus, there will be one solution. When it is larger than 0, it will be as per the previously drawn diagram at the start. So there will be b minus the minus b plus or minus a value, so +1, -1, whatever the different values are, which means there are two solutions. And if this is less than 0, then we have square root of a negative number which is undefined inside the real space, which therefore means 0 solutions. In other words, the graph does not intersect with the x-axis. All right, guys, I really hope this was helpful. It's always good to do things like this to test your brain a little bit. As you would have seen earlier, the trick to this one is to remember that x plus d all squared, what that equals, and then making the equation look something like that, and you'll be able to break this down pretty simply. But I really hope this was helpful to explaining how you can generate the quadratic formula from first principles. And as always, good luck with your maths and stay safe out there.